All right, this is the last video for this section on trig. So for this one, we're going to go through, and the last video, we started with the angle and then we determined all the trig values. Well, this time I'm going to give you a trig value and what quadrant, and we're going to figure out the remaining ones. All right, so let's get this rolling. So the first one is, all right, if cosine of theta is equal to negative 12/13 and theta lies in quadrant 3, determine the values of the remaining trig functions. All right. We don't care what the angle is. So I want to make that abundantly clear right off the bat. So we don't care what the angle is. We don't care if it's drawn to scale. We just care about getting all the information into the quadrant and then determining the rest of it. So first thing I need to do, besides click on the pen and get me a right color so I can see, there we go, is go into quadrant 3, and I'm just going to make a triangle. I don't really care if it's the right angle. All I care about is getting it to look like something I can use. So now cosine, remember, is the adjacent side divided by the hypotenuse. So what this tells me is that the adjacent side here is 12 and the hypotenuse is 13. Okay, and we know it's negative, but if you look at it, it's because this side's going to be a negative value, and so is this side. But I need to figure out this side. All right, so I don't know this value, and we know that value is y. So I'm going to go through and use the Pythagorean theorem to go through and determine what the other side is. So 12 squared plus y squared is equal to 13 squared. 144 plus y squared is equal to 169. Go ahead and finish this out, and I'm going to end up with y squared is 25, which means y equals either plus or minus 5, depending upon which direction I'm going. Well, right now we see we're in the negative, so this is negative 5. Now I have all, it's a really bad looking 5, but you get the idea. So it's negative 5. I need to go through and figure out all the other functions. Okay, so then that means that sine of this theta is the opposite side divided by the hypotenuse. So that's negative 5/13. Cosine we already know, but I'm going to put it in here just to make my life a little bit easier. Okay, tangent. So yes, tangent is equal to sine over cosine, but I don't feel like doing that mathematics. I'm just going to look at my triangle. So then that's going to be the opposite side divided by the adjacent side, so that's just 5/12. Cosecant theta is the reciprocal of sine, so that's negative 13/5. Secant theta is the reciprocal of cosine, so that's negative 13/12. And then cotangent theta is equal to the reciprocal of tangent, so that's 12/5. Me personally, I like drawing it out because I get a better visual. I still have to use the Pythagorean theorem, so it's up to you if you want to go through and do it either using the visual or if you would rather do this using the identities. You could have taken negative 12/13, put that into the Pythagorean identity, and then figured out what sine was, and then use the other identities to figure out the other values. It's entirely up to you. Me personally, I like being able to visualize, and I know that most of my students like that, but there are some students that will just like to go through and just do the algebraic version, and it's perfectly fine. This one's a little bit different. We're going to start with a cosecant at 5/4, and then it's telling me that theta lies between pi over 2 and pi. So we got to figure out what quadrant that is. So if here's 0, pi divided by 2, here's pi, again this is 3 pi divided by 2, so we're going in the positive direction. We're going to end up in quadrant 2. Again, I care not what the triangle is for its angles. I don't care. I'm just going through and trying to figure out what are the side lengths for now, so I can figure out all of the other functions that we have here. So cosecant we know is 5/4, so we know that right off the bat. And then we know that sine is the reciprocal of that, so that's 4/5. So then the opposite side is 4, and the hypotenuse is 5. And hopefully we remember that there is a special triangle. It's a Pythagorean triple where it's a 3, 4, 5 right triangle. If you don't remember that, now you know. There's a 3, 4, 5 right triangle. So this is, whoa, that's a 3. It looks really not like a 3, but now it looks like a 3. So we've got a 3, 4, 5 right triangle. This is going in the negative direction, so I'm going to put a negative sign in front. And now we're going to go through and figure out what cosine is. So cosine is adjacent over the hypotenuse. So negative 3/5. Tangent is opposite over adjacent, so negative 4/3. Secant is the reciprocal of cosine, so negative 5/3. And cotangent is the reciprocal of tangent, so that is negative 3/4. Now, the two examples I gave you had Pythagorean triples as our relationships, but it could be any relationship. You could have one side be 17 and the hypotenuse be 22, and you would just have to deal with square roots in the other locations. So just because these come out pretty nice, does not mean that every single one will come out that way. So just be aware as you move through and try other problems in addition to these. All right, so thank you very much for your time and your patience, and have a great rest of your day.